Hi guys, this video is going to help you with today's assignment, which is on finding the volume of cylinders, cones, and spheres. So when we go ahead and find the volume, we're going to be having to use formulas. Using these formulas, and it's very important that we always write them down and that we follow exactly what the formula says for us to use in order for us to find the volume. Now in your formula chart, you're going to find a section titled volume. Now you do have the option for prism and cylinder on the first row. So the volume for a prism and a cylinder is found in the same way. And since we're going to be working with cylinders today, I'm going to be using this one, which is volume is equal to capital B times H. And then we're also going to be working with cones, which is volume is equal to 1/3 capital B times H. And then we're also going to be working with spheres. Volume is equal to 4/3 pi r to the power of 3. Now, we're going to be plugging numbers or values into our formulas, but specifically, if you notice, this capital B is coming up in both the volume of a cylinder and the volume of a cone. Now, it does not come up in the volume of a sphere, and that makes sense because a sphere doesn't have a base, right? So we know that the cylinders and cones do have bases. So that's the reason why it has the capital B. Now specifically, the capital B, every time that we see it, we need to think to ourselves, is the area of the base. So for example, a cylinder specifically actually has two bases, right? But when we're finding the area of the base, since the two bases of a cylinder are congruent, really we're finding the area of that circular base, either one of them, okay? Now, in a cone also has a base. It only has one base, but it does have a base. So it kind of looks like this. Also circular base, right? So if you think about this, for both the cylinder and the cone, the base is a circle, and therefore we're going to be having to find the area of a circular base. So, how do we find the area of a circle? Excuse me. Because after all, the bases of a cylinder are circles. The base of the cone is a circle. So if we're having to find the area of the base, that means we're having to find the area of a circle. So how do we find this? And in your formula chart, you're going to find that there's a formula for area of a circle, which is area is equal to pi r squared. So this is exactly how we find the area of the base when we're trying to find the capital B value in these two specific formulas. That is something that we need to keep in mind. All right, let's go ahead and practice. Example 1, find the volume of the cylinder and use 3.14 for pi. So I can see right here that I have a cylinder. I need to go ahead and notice what's going on in my diagram right here. Obviously, I can see that it is a cylinder, but they're giving me a dimension right here, which is 12 inches. Now, this dimension is not telling me the area of the base. It is only just telling me the diameter of the circular base, because the diameter is the distance measuring from one end of the circle, passing through the center of the circle, and going all the way to the other end of the circle. So that's our diameter right there. Now our height is demonstrated by this other value right here. Remember, the height of a cylinder is always the distance from one base to the other. So this right here is the height of the cylinder. All right, so let's start off by, now that we analyzed our picture, writing down our formula. So volume is equal to capital B times H. Now remember that capital B is the area of the base and H is the height of the cylinder. Now I do know the height of the cylinder, but I don't know the area of the base just yet. I need to go ahead and find those two values. So I'm going to go ahead and find them over here on the side. B equals, and then H equals. So I know that H equals 9. That was given to me. Area of the base was not given to me. Now remember, area of the base is the area of this circular base right here. So I'm going to shade in the base. I need to go ahead and find the area of that base right there. So I'm going to draw myself a circle. And remember that the way that we find the area of a circle is pi r squared. Now r stands for radius, and a radius is measurement from the center of the circle touching the circle. This is our radius. Now look at your diagram. 12 is not the radius. We need to go ahead and cut that in half. So if I do 12 divided by 2, that's going to give me 6. So now I know the measurement from the center touching the circle is 6, which is our radius, which is what I needed to know. So let's go ahead and find our area of the base. Now they did tell us to use 3.14 for pi, so I'm going to go ahead and calculate 3.14 times radius squared. That would be 6 to the power of 2. And that's going to go ahead and give us our area of the base. So let's go ahead and go to our calculator. 3.14 times 6 to the power of 2, enter. Now we could have just expanded that and we could have said 3.14 times 6 times 6, and we get the same thing. So either way, we are going to get our answer there. Now this is 113.04, and that is going to be our area of the base. So I have the two values that I need. I get to plug them in now. So volume is equal to, plug that in, area of the base 113.04, and the height, which is 9. And now I just go to my calculator and I go ahead and multiply this times the 9, which is the height, enter, and we get our final answer, 1017.36. Volume is approximately 1017.36. Now remember that volume is measured in cubic units, so I'm going to say the volume is approximately 1017.36 inches cubed. And we are done. Let's go ahead and move on to the next one. Find the volume of the cylinder. Now remember, the formula for the cylinder does go like this. Volume is equal to 1/3 area of the base times the height. So once again, I need to go ahead and find those two values right there. Let's go ahead and take a look at our diagram. So I do notice that they're giving me the diameter. So 6 is the diameter. And then I do notice that they're giving me the height, right? Because from the base touching the apex of this cone, that's going to give us the height. So I need to go ahead and find those two values right here. So area of the base and the height. The height I already know. Now the base is a circle. And if I need to find the area of the base, I need to know the radius. So once again, I can see the circular base right here. But remember that the way that we find the area of a circle is pi r squared. So I need to know the radius. And so if I go to my diagram, once again, I'm going to have to divide that by 2 in order for us to get half of 6. So 6 divided by 2, that's going to give us 3. So now I know that from the center touching the circle is a radius of 3. So now I have all the information that I need to find my area of the base. So 3.14 times 3 squared. So we're going to go ahead and go on to our calculator. 3.14 times 3 squared, enter, 28.26. So our area of the base is going to be 28.26. So now we have the two values that we needed. We're ready to plug in our values. Now don't forget, this one does contain a 1/3 as part of the formula, and it's super important we don't forget it. Okay, now that I have my numbers plugged in, I get to go ahead and go to my calculator. I'm going to use my parentheses to enter my fraction altogether, times the area of the base, which is 28.26, times the height of that cone, which is 7. So I have every component of my formula. 1/3 times area of the base times the height, enter, and we're going to get a volume of 65.94 approximately. Now the reason why I have to use my approximation sign right here is because after all, I'm always using only just an approximation of pi. So my final answer is also an approximation. Now this is volume, and volume is measured in cubic units. I'm going to say volume is approximately 65.94 meters cubed. And I'm done. Okay, so that was the volume of a cone. Lastly, let's go ahead and practice finding the volume of a cylinder. So the volume of a cylinder formula goes like this. Volume is equal to 4/3 pi r to the power of 3. Now let's go ahead and analyze our picture right here. So I do have a 3 measuring the distance from one end of the sphere passing through the center all the way to the other end of the sphere. So I know this is a diameter. Let's go ahead and see what numbers we need to know in order for us to plug it into our formula. We need to know the radius. So this number is not the radius, and the way that I find the radius would be dividing that diameter by 2. So 3 divided by 2, that's going to give us a 1.5. So now I know that from the center all the way touching the outside of that sphere is a measurement of 1.5, which is the radius. And that is pretty much all that I needed to know. I just needed to know the radius. This time I don't need to know the area of the base. Obviously the sphere doesn't have a base. I don't need to know the height. Radius is all that I need to know. So we're ready to plug in our numbers. Volume is equal to 4/3. Now they did tell us to use an approximation of pi of 3.14. And then I'm going to go ahead and plug in the radius that I found. And then pretty much from here, I'm ready to plug in my numbers into my calculator. So parentheses 4 divided by 3, close parentheses, times pi times radius to the power of 3. So I have everything entered in exactly as my formula states, and I press enter. So this is the volume of that sphere, 14.13. So volume is approximately 14.13. Again, it's an approximation because I'm using an approximation of pi. Remember, volume is measured in cubic units. So volume of this sphere is approximately 14.13 centimeters cubed. And I'm done. Okay guys, so I hope that this video is going to help you answer the questions in today's assignment. And if you have any questions, feel free to email me or send me a message on Schoology. Thank you.